In the attention, as you already know about the sequence to sequence, the basic sequence to sequence means the model stops making prediction after outputting the end of sentence. So you have the encoder and then you have the decoder. So after we got the end of sentence, we stop. Okay, so after this one, we stop. This is the basic sequence to sequence. But we can also apply the attention mechanism. The attention mechanism means this is the enhancements to the basic sequence to sequence. The attention mechanism allows the model to focus on the different parts of the input sequence at its steps of the output generation. It means when I know there is an output here, then I will put a kind of attention. When I know there is an output here, so I will put another attention. And now there is another output here, so I can put another attention. And every of this attention will give you a more confidence to generate the output. So this helps in handling longer sequences more effectively. Because whenever you do an output, there will be attention. Whenever you do an output, there will be attention until the end of the sentence. That's why we call it, this is a sequence to sequence with attention. So every time when we do the encoding, okay, after we finish, for example, hi, I am fine. So we will do the RNN. For example, in this case, yeah, we do the RNN like this one. And then we have a matrix. In this node, we have a matrix. And we also include the next word, which is I. And we produce another hidden state. And we have another matrix. And then we produce another hidden state. And we produce another matrix. And so on. Let's say we have H1, H2, H3, H4, H5. And then we can apply the attention mechanism. If I know this hidden state, if I know this hidden state, and if I know this hidden state, I will check for every of these hidden state. I have a new matrix to determine what is the possible output. So I put the attention on some of the words that we have from the input. So I will have another input, for example, I am fine. So I will produce a hidden state. M will produce hidden state. Fine will produce hidden state. And every node or every hidden state produced here, it will be considered to check the output on the second word. So we say this is a combination. So we want to put an attention in order to produce a better output. This is sequence to sequence with attention. So the attention mechanism, it was proposed in 2017. It is a function. And this function, it is a mapping of a query and a set of key value pairs to an output. So we have a query. And then we have a key and value, key and value, key and value. where the query, keys, values, and output, all of them are factors. So the output is computed as weighted sum of the values, where the weight assigned to each value is computed by a compatibility function of the query with the corresponding key. So let's say we have the key and value. So we will do the multiplication with the query. We will do the multiplication of key and value with the query. We will do the multiplication of key and value with the query. The query and the key value pairs are used in the newly proposed attention mechanism that is used in the transformer. So this part, we call it, this is a transformer. Once you have a query, we will do this transformer in order to get the attention value. So these inputs for the attention mechanism are obtained through multiplication of the general input of the encoder or decoder with different weight matrices, as can see in the figures. So every this one will have different weight matrices. So in this case, it will have weight matrices. This also has another weight matrices, and this part also has another weight matrices. Let's see an example. Okay, I think it's difficult to understand the theory, so let's look at an example. Now I have Q, K, and V. So the dimensionality for each of them, let's say it is 1. Okay. The factor or the length of the vector is 1. It is just for simplicity. But actually later on, if you look at the K, Q, and V, the dimensionality is not 1. It will be very, very huge. Maybe sometimes it can be like 10,000. Yeah, in some cases, a big model, you can have like 10 million. Okay. Or in some other large language model, you have like 17 billion parameters and so on. So now let's make it very simple with one dimension. Suppose we have 3 words in the sentence. Alice is kind. So these 3 words, this is kind. And I'm going to focus on the query, or in this case, we want the model to focus on the word kind. So we want to focus on the word kind. So I can say that this is the query, or this is the Q. And we want to evaluate how much attention it should give to each one. So we want to make the attention value. So the attention value will be used for the modeling. Now let's suppose that be the query or the Q vectors for kind is 2. Okay. So the higher value is more important than the other, because we are just doing the query for kind, so we can get a value of 2 for kind, but there is no value for other words. And then for every of words, we have key factors and we have value factors. The key factors, usually it is representing a kind of the standard factors for the word. For example, the K of Alice is 1. The K of is 0.5. And the K of kind is 2. So sometimes this is just an initial value for the key. V, we have V as also a factors representing the meaning of each word. So the meaning of each word, we have also another kind of value. So this value is based on a kind of model. So if you use like ChatGPT, so they have the value in their model. If you use like Gemini, then they have another value for this word and so on. So Alice, for example, we have the value of 10. Is, we have the value of 20, and kind, we have the value of 30. It is based on the meaning of each word. Now I can represent those values into a table like this one. Alice is kind. So the Q or the query give a value of 2 for kind, but no value for the other words. For the K, Alice is 1, is 0.5, and kind is 2. For the V, here we have 10, 20, and 30. Next, we need to calculate the attention score. The attention score means we want to multiply the Q and K. Q and K. So for each word, we compute the attention score by taking the dot product. Dot product means multiplication. So the multiplication is based on the Q and K. Okay. So if you look at the previous picture, this one, we are going to apply the multiplication from the Q and K. And then after that, we follow with the value and so on. Okay. Now we will do the multiplication for Q, because we have the Q is kind and we set a value is 2, then let's apply. Now K multiplied by the Q multiplied by the K Alice. Q multiplied by the K is, and Q is multiplied by the K kind. We can get this value. So we call this is X. X is a value of the multiplication between the Q and K. Q and K, Q and K. After we have this value, we can apply a kind of function. Yeah, you can apply the logistic function. You can apply a ReLU function. You can apply tangent function. Okay. Now let me just use softmax to get the attention weight. The attention weight, to get the attention weight, we apply the softmax function to the scores. What is softmax? So this is the softmax function. The softmax of xi, okay, so in this case, the x that we produce from the attention score, we will do the exponent of e. E is an E number. This is 2.7 something something. We will do the e power of xi divided by the summation of e power xj for all j. So what does it mean? We have 3 words. We have Alice, is, and kind. So for the word Alice, the value of xi, the value of xi is 2. Then it means we will do the e power of 2 divided by the sigma. Sigma is the summation of exj. J means the words on your sentences. So how many words do we have? It is Alice, is, I. Then it means we will do the division with e power of 2, this one, plus e power of 1, which is from the word is, and then we do with the e power of 4, which is the word kind. And we can get, the summation is 7.39 plus 2.72 plus 54.60. So this is the result. Then we can get the weight for Alice is this one, 7.39 divided by 64.71. This is for Alice. What about the weight for kind? The weight for kind means we have the e power of 4 divided by e power of 2 plus e power of 1 plus e power of 4. Then we got this number, and this is the weight for the word kind. After we got this value, okay, let me put it into a table. So this is the value from e power of x, and then this is the weight that we produce. Okay, this is the weight, this is the weight, and this is the weight. So finally, we will make the attention value. So the attention value means we will multiply weights by values to get the final attention output. We will multiply its weight by its corresponding value. So every of this value, we have the weight, we will multiply with the value. W, we will multiply with V. So for the word Alice, the weight is 0.114. We will multiply with the value, which is 10. We got the output, this one. The second one is we have the weight is this one and multiply with the value 20. We got this one. And the last one, kind, we got this weight and we got the value. Then we got this one. In overall, you can have a kind of summation for the output. So the summation will be 1.14 plus 0.84 plus 25.29. The final output of the attention mechanism for focusing kind is 27.27. This shows that the model mostly focus on the word kind, which has the highest weight, followed by Alice and is, which much lower attention weight. So you can see here, this is the highest one. So you can, sometimes we can make the proportion 25.29 divided by 27. So the proportion is high. Then we can focus that this is the word that we need to pay attention. Compared to the word Alice, which is very small, and is the smallest. Okay. Then we will get this attention value, and we can do the modeling based on this attention score. Okay, I think I will stop here. So I will continue to discuss this one tomorrow. Okay, any questions?